Okay, I think we'll get started here. So I'm going to tell you a little story about something we're working on that has not come to fruition yet, and it's an initiative around factory-built housing, which potentially could be an enabler, I think, for integration of intelligent building operations. And so it's a question mark. So it's really looking for input from you too. So I'll provide an overview of this new program at NSF, which could fund this effort, and then talk about why factory-built housing might make sense, an overview, a little pitch about our proposal to this NSF program, and then a couple discussion points about intelligent operations in this context. So NSF Engines, it's a new program at NSF in a new directorate called the TIPS Directorate. That is much more applied, less really fundamental research. It's really about, this particular program is about catalyzing and accelerating region-based, sort of ecosystem that's R&D based, but has significant components of translation to practice or commercialization and workforce development. So it's really meant to address topics that are critical technologies or address societal challenges that can promote economic growth, job creation in a particular region. They want to create Silicon Valley kind of things, in different places around the country. From an academic side of things, $160 million over 10 years is a very significant grant. Purdue has never received a grant that large, okay? That's how big that is. We went after it in the first round, the very first round of this, which was started about 2 years ago. We got pretty far. We got to the semifinals. And so we had a virtual site visit. Did not make it, but they liked our proposal, so they gave us $1 million just as a consolation prize to continue to develop the ecosystem. There were 10 engines that were awarded, and there were 58 development grants. So. And then the second round, we just launched our development grant. The second round was just announced in April, and so we're going to go after that. So the innovation engine model has three components. Use-inspired research, so applied research, not typical of NSF. The translation of innovation into society, that's really the commercialization connection to industry. And then a significant component, of the effort would be workforce development. So the timeline here, looking at the next round, we got our development grant. We just launched it in March. The next round got announced in April. There's only one submission per institution, so we had to compete within Purdue. And we were chosen as the submission from Purdue, which was great. We're getting a lot of support from Purdue administration to do this. I'll talk about that a little bit later. We submitted a letter of intent. Pre-proposal is already due in August, early August. But then it's a pre-proposal, and then you'll be invited to submit a full proposal, those that pass mustered in February. Okay, so why factory-built housing? Housing is a tremendous societal concern, right? There's a tremendous shortage of housing, particularly affordable housing in lower income populations. Even within this region, we have, I think when you look at lower income populations, you have for every 100 families or people looking for housing, there's only about 30 or so housing units available. There's a tremendous shortage. There's a shortage of skilled labor in the housing, construction and services. The housing, sector is a significant sector in terms of energy and global impact. It's like something like 20-something% of primary energy and associated global warming associated with that. Buildings altogether, about 74% electricity usage is in buildings, and in residential is half or something of that. And housing is, increasingly vulnerable, right, to natural weather disasters like, Fort Myers wiped out, right? We have to now all of a sudden replace all that housing very quickly, and that's an issue. And in our area, we develop like technology. We've done a lot of research. I've done a lot of work on fault detection diagnostics, MPC, a lot of things over the years. It's really hard to get uptake into the market of buildings in general and housing, because site built, right? There's no opportunity to test new building designs in a lab. There's no, it's really risky to bring things out into the field. It's such a diffuse sort of market delivery, right? So factory-built housing has the promise, and has had the promise of addressing a lot of things. You can improve consistency, quality of the end product, reduces the risk of incorporating new technologies. Potentially, you could reduce the cost of building materials and components by just buying at larger scale, right? And you can address potentially shortages of skilled labor and workforce, really by doing things in the factory, right? In a more organized, centralized way, with more training associated with that, and then bringing other populations into the construction of housing, more women, building housing than you have in the current sort of way we do things. Reduces material waste. Really important thing that people are most interested in this sector right now is reducing the time to deliver. And it's more predictable, when you can deliver housing. And that has some implications for, being able to react quickly to natural disasters and replacing housing. In the US, less than about 6% of new housing is built in factories. It's mostly this sort of volumetric approach where you build large sections of factory and deliver on a flatbed truck. It's typically just doing traditional construction, but in the factory. There's very little use of automation or new techniques, in the current. In Europe, it's a little bit different. It's more a panelized sort of approach where you build wall panels. A lot of times those wall panels are delivered to the site. Sometimes they're built into volumetric sections, depends upon the company. Much higher quality of housing. That's actually, I just visited a company in Italy. That's one of their end products, built from panels, at the site. It's a whole different deal. And in Japan, it's a different deal too. So, but in the US, we got some obstacles. We've got, kind of a poor public perception of factory-built housing, right? Manufactured housing. I think one of the limitations of the US is people want customization, and the things that are offered tend to be choose from this or that. You don't have a lot of flexibility. The volumetric delivery can be a problem in some cases, right? And really, you still don't see much evolution or revolution in housing technology because they're, it's again using more traditional approaches, and they don't really have the staff and the scale, the ecosystem to support, the sort of design processes that you would employ in like mass-produced products like automobiles. Local codes can be an issue. Financing, unfamiliarity with financing for this kind of housing can be an issue. And there are some high-profile failures, okay, like Katera in California, kind of hurt the ability of companies to raise money in that space. They haven't really demonstrated the cost advantages, which should be there, right? But you need steady volumes of production. You need repeatability of design for cost effectiveness. You need automation, right? And automation hasn't really arrived to any great degree in the factory-built housing industry in the US. There's labor shortages within the housing industry, factory-built housing industry that does exist. And there isn't, nobody has scale, right? So there's a lack of this sort of innovation ecosystem, R&D labs and venture capital and things like that. So very few companies employing automation at any scale. And that may be due to the need for customization and the high setup costs. What we want to go after is trying to componentize and standardize individual pieces that you can put together in different ways to try to make it, to productize it more and to be able to automate things at larger scale, right? Again, these are more smaller players. There's relatively little vertical integration. It really involves putting a lot of different people together to deliver housing still in that sort of space. Okay, so our proposal is based upon a vision where we try to productize future housing through off-site industrialized construction, automation, componentization of modular elements that can be assembled in different ways, engineered modular elements that you can put together in different ways, like Legos, think of Legos, right? To enable what we call mass customization and really have it be able to outsource to suppliers and have a robust supply chain that could feed standardized elements together, and you have companies that basically put that together as a finished product. So this kind of shows one example of that. Maybe you're delivering, in the Midwest from a supply chain locally, and then you're using automation to build these home kits to get delivered to the site, either assembled at the site or assembled partially at the factory, whatever makes the most sense to deliver better, more affordable, higher performance housing. So in the first round, so our region of service is Indiana and half of Michigan. We had 6 core partners, which represented sort of major universities, but also community colleges. And then Purdue Global, which is an educational platform that Purdue offers. And so we had these universities. We also had some secondary partners outside the region. National Renewable Energy Lab has a program in industrialized construction. They were part of it. We had this health organization in Minneapolis, the Well Living Lab, right, that focuses on indoor environmental health as part of it. And we had companies, a lot of companies. We signed up 23 companies to join an industry consortium. We had support of the states, both in Indiana and Michigan, Economic Development Corporation, the Workforce Development, the housing authorities in those states, and the national industry organizations like the Modular Building Institute, part of it, National Association of Home Builders. And the goal, of course, was to deliver really better housing at lower cost, lower the barriers to home ownership, deliver better homes with lower electrical demand, lower global warming potential, lower the barriers for new technology adoption, so you can continually be delivering technology at a larger scale to products that are marketed. 3 parts to it. Again, there's an R&D part. A core thing in our R&D proposal was to develop the tool chains that would allow you to go from configuration of standardized elements to a customization of a product, to automated manufacturing, in terms of processing and assembly in the factory. That whole tool chain, which Michigan people have been working on, the Taubman School of Architecture there. So that's a key part of it. But then the things we already do, like in more sustainable materials, high technology, products like, heat pumps, high performance heat pumps, things like that, would part of that in the context of manufactured housing. Translation to practice was focused on really connecting to industry. And I'll show a little bit about that. Workforce development, we had a plan which included all aspects of what's needed, architecture, engineering, manufacturing, construction, sales, field support, the whole chain, right? But the really exciting thing for me, and the reason one of the reasons I was really excited to be sort of leading this effort was to build a new building that would allow us to basically study modular housing at scale. Okay, it had three elements to it. So one is that in the right side there was an area where you could test sort of automated manufacturing tool chains, right? Robotics, stuff. And then in the left top corner there was a full-scale environmental chamber where you could emulate environmental conditions anywhere in the U.S., right? So Houston, Minnesota, but not just temperature and humidity, solar emulation, wind, right? And where you had a modular housing platform that you could put together modular elements and test elements of the housing, at scale, right? And as an integrated system. So to me, that was super exciting. And then we had some classrooms for training the trainer programs as part of the workforce development effort. And then the industrial consortium was a big part of this. We have a consortium where we work, we meet all the time. They can leverage the NSF money. They put in some money of their own, right, to direct things that are maybe more near term. And it's not just the people that are doing factory-built housing, but it's the whole supply chain, right, the people that would supply to that. And it's really for translation of things that would be developed in the center. Oh, and also the workforce development programs, into practice. So So just some examples of things that we work on, that could be things that could be delivered into future housing. There's a woman that does engineered wood, okay, which is, sequestering, carbon, right? It's a very sustainable material. She's developed wood that is, that has a very low solar absorptance, but a high emissivity for long-wave radiation through the atmospheric window. So it actually cools 10 degrees C below the ambient on a summer day, right? So made out of wood, right? She's developed, and other people, working on these topics too. She's developed windows that are made from wood. Basically, you just remove the lignin, right? And you can make wood transparent. She's developed wood that has really high insulating value by the orientation of the cellulose fibers and removal of other substances. So things like that, could be part of this. We are interested in new ways of delivering comfort. So we have been working on, we have something called a Human Building Interactions Lab, where we can test new concepts over at the Herrick Labs, where you can test basically radiant heating or cooling systems. But we developed a wall-embedded micro heat pump. So a heat pump that's embedded in the wall that could be produced in a factory and assembled on site. And we can test it in this Human Building Interactions Lab, and we can test new ways of interacting with these modular elements, through audio, visual interfaces. So that's a part of the things we do. So, okay, so is this an enabler for intelligent building operations to have have housing as a manufactured, productized thing, right? I think so. I think, if you have modularized housing, you could have, elements that have embedded intelligence, right? You could have elements that have integrated into factory sensing, communication, occupant interfaces, models, right? Integrated fault detection, embedded in that modular manufactured elements. That integrated models, maybe have some low-cost sensors, but then the models give you outputs that you call virtual sensors that can provide useful things for model predictive control, energy fluxes, right? Power consumption. You don't have to necessarily have a power meter. You could have a model for the power with other more inexpensive measurements and have a map, right, for water heater. And you could use that for, controls, at the local level, but also available to the system, basically coordinator for the house, performance monitoring, fault detection, things like that, right? You could have embedded audio and visual interfaces in those modular elements. And that would support, high feedback to basically, to operations. Whole building intelligence, right? And utilizing those individual models, to generate a whole house model to provide grid responsive controls, overall, basically fault detection and diagnostics, information that's needed for service, warranty. Maybe you're delivering housing as a product and you provide a 10-year warranty for that house, and now you have basically much better tools for sort of managing that warranty information. You could have this as part of a community that's maybe multifamily housing to do community energy management. So, and so those whole building models, again, could be generated from the individual modular element models to enable model predictive control, whole building fault detection diagnostics. And the utilization of, this engineered and factory-built modular elements with embedded intelligence assembled into a house could dramatically reduce the cost, I think, of delivering intelligent building operation features at scale and productize, basically, IBO. So that's my pitch. And I'm interested in your thoughts. This is just an example, one of my colleagues has done with community energy gamification, and it's basically an add-on to the field, right? Where, we put tablets and we put Alexa in every, room, apartment, basically, in the multifamily housing, and made games, right? Made it available for the participants who sign on to actually get monetary rewards. They get an energy score. They get entered into a lottery. Their chances of winning a lottery is like the NBA draft. Improve the better their performance, kind of the inverse of the lottery of the NBA draft. And they love it, right? The people, this was done in affordable housing. and it led to some significant savings and lots of participation. So another example of what we could do. But anyway, thoughts on this idea? Yeah. I'm sorry. Thank you.
No problem. Thank you. I think it sounds first of all a very interesting project. Good luck with that. It's an immense budget. The things you could do with that.
Yeah.
To answer your question, I do think it would be an enabler for IBO. The primary reason that I see is that, at least in my experience in Europe and in Belgium, is that the market is so fragmented. Because you've got an architect, you've got an engineering office, you've got a constructor, subcontractor, you've got the controls company, etc. And the field is set right now. And for us as a new player to enter there, you have to agree with all of those and try to fit your spot. And that, in practice, gives a lot of problems with interfacing with existing systems. And if you're in control of the whole supply chain, and you're doing all these things, you can set this is how we're going to do it. And that's a huge difference. And if you have such a big project and you know, okay, we are going to build hundreds of homes, then scalability is guaranteed. And it's things like that that I think it could make a big difference. And of course, you still have to do it then, but at least, yeah, you've got an idea where it's all going to, and you can put budgets on it and things like that.
Yep.
So, yeah.
Yep. Very cool. Yes.
Yeah. Thank you, Jim. Yeah, it's a great project. I agree with everything you said, like standardization, especially on the interface and all of that would definitely enable deployment at scale or coordination and everything you mentioned. So at the very beginning, you mentioned of successful case studies in Italy, Europe, and Japan. I was wondering, like, if those companies are operating at scale, and if so, like, why they don't try to enter the U.S. market, or like, did you have that kind of discussion with?
Yeah. So you know, I'm relatively new, I will say, to the whole factory-built housing sort of understanding of industry and what's out there, right? So I went and visited a number of factories in Italy, and to answer your question, no, they're not at scale. And so there are a lot of relatively small, some bigger than others, and they're integrating some automation, you know, into the facilities, but not the scale that they want to. Some of them have ambition for growing, right? And they're doing interesting things, but they're all still, you know, relatively small players. Now, I understand that there's, you know, some big players. There's a big player in particular in Japan that has a huge part of the Japanese market where you have, I think, a pretty thriving industry there. And they recently, just in the last year, bought Remington Homes in the U.S., which is one of the largest home builders in the U.S. And so they probably, I haven't talked to them, but, you know, they may have plans, right? There may be some players out there that do have the scale. I'm just learning about them, but that's an excellent question. Yeah.
Thanks.
Might not directly link to the question IBO. Do you foresee existing building codes, how much it may change or has to be adapted to factory-made houses?
Yeah, that's a great question. That is a real challenge if you're to manage all the different codes that exist in different states and different localities, right? If you want to be a big player across the U.S. and be able to manage all that, I think, right? And right now, I understand there are actually companies that specialize just in managing those codes, you know, sort of the interface between companies that produce factory-built housing, I'm talking about in the U.S., and delivery, basically, the people that are going to put it together at the site, right? Because they don't have a whole vertical chain, right? These companies, they have to rely on a lot of different players to do it. So there are companies that specialize exactly in that, right? So, but you would think that that could potentially be streamlined. So where if you had a standardized component that is going to be part of a manufactured housing, that component can satisfy the codes, right? But then there's got to be another step of the whole assembly has to satisfy the code. So there's always going to be somewhat of a challenge we're going to have to work through. But yeah, it is one of the bigger challenges is to handle that.
Thanks. I wanted to know what you thought the range it would be for the end consumer, the cost-wise, like just a ballpark.
Yeah. So and I haven't seen any really definitive studies on this, but it's been estimated that cost savings should be on the order of 30 to 40%. If things were to scale up, right? And there's material savings, there's purchasing things at larger scale. I've seen those numbers, but if you look at the data that's out there in terms of the comparison between factory-built housing and site-built housing, there's no savings. There's no savings in terms of cost yet in this country. I don't know about other countries. So it hasn't been realized, and that's one of the things that's holding it back. But the delivery time is definitely something that's well documented. The delivery times are dramatically reduced, and the predictability of being able to deliver housing. And that's really what's allowing the industry to grow kind of incrementally, but not very quickly.
And then this is not so much a question, but could you go back to the slide of the Italian modular?
Sure.
It's probably a little bit back.
Yeah, that's all right. All right.
So that looks really, really nice.
Yes.
And then you had an American example later.
I gave a bad American example. Let me tell you, well, first of all, in Italy, it's a whole different expectation about housing. You couldn't find something like that in Italy, right? Because there'd be no market for anything that's shown above, right? In the U.S., you have a market for the whole range, right? So you can find companies in the U.S. that are producing just beautiful, housing that's built in a factory, no question about it. I just gave an example which is given a bad reputation to factory built or manufactured housing in the U.S., right? But you go, and particularly out west, like in California and in Utah and in Colorado, you find some companies that are producing some beautiful products.
I think if
Absolutely.
you can make them cool, kind of like how
Exactly.
for a moment Tesla made electric cars cool.
Yeah, that's a great analogy. Yeah.
And then what happened?
Good. Okay, well, and we're interested in partners that are interested in this topic. So anybody that wants to follow up on this, happy to talk more about it. So, Arash, do we have? We do. Okay. So I think we're ready to. Yeah. Subu, I think we need some help setting up what we need to do here. Thank you.